Hello again. Welcome to the second part of Science and Principles. This is part 2, where we looked at some things in part 1, where we talked about voltage, resistance and current. And now we're going to have a look at a little practical circuit just to visualize this. So in this circuit we have, first of all, on the board we've got a place there where we can connect a voltage or battery into it. The battery will then run through this variable resistor here, or the current will run through this variable resistor here, and then back to the battery. So here's our voltage, here's our resistance, and obviously the current will be flowing in the wires on the circuit. So first of all, what we're going to look at is this variable resistor. Now, if I connect this test meter to the variable resistor, I'm not going to put the probes on there because I need some free hands to work. So what I'm going to do is I'm just going to connect them on using a pair of flying leads and crocodile clips. And then if you look at the meter, what I'm going to do is I'm going to adjust this resistance. And what you should see is we're set to the ohm setting and 200k, so it's a reasonably high resistance. And as I adjust this, you should see the numbers change on the multimeter, telling us the resistance at that point of the variable resistor that we're going to use. So what I'm going to do, I'm just going to alter the resistance of this, and as I turn it, you should now be able to see the resistance of that circuit increasing. And I'm going to stop at a fixed point about there, about 20,000 ohms or so, maybe a little bit less. I'm going to see how close I can get into 20, there we go, 20,000 ohms. Are we going to make a note of that number as well? So I'm going to say 20,000 or 20 kilo ohms. Now what I'm going to do is introduce a voltage into the circuit. Okay, so first of all we're going to put a 9-volt battery into the circuit, but let's make sure it's about 9 volts first of all. So I've changed now the setting on the multimeter, and that's up to 20 volts because we know this is going to be in the order of about 9 volts. So if I just put the test probes on the battery, we can see that that's going to be 9.04 volts. We call it 9.04. Now what we're going to do, we want to look at the current in this circuit with this voltage. So in order to do that, I'm going to need to change the settings on the multimeter. So I've got to change the lead from volts and ohms over to amps. And then I'm going to change the current range to 200 milliamps. Then what I have to do, as we said in the previous video, that we have to connect the ammeter into the circuit. So I'm going to break the circuit by taking that lead to that line on the breadboard, and then I'm going to put in 2 connections. So I can connect the ammeter into the circuit. And I'm going to do that again by using these flying leads. So then I've got some free hands to work with. So at the minute we've got no current running in the circuit because I haven't put any voltage in. But now if I connect up, we should now see a current running. Now we've got this set to 200 milliamps. So that is going to be 0.4 of a milliamp. So it's not 0.4 of a thousandth of an amp. So that means that our current is going to be 0.0004 of an amp. I'm now going to change the voltage, and I'm going to put a second voltage in. I've changed the configuration on the meter to read voltage again and set the range to 20 volts. Now we've got two 1.5 volt batteries. So with batteries connected in series, we add the voltages together. So if I measure this now, because it's two 1.5s, we know that it's going to be in the order of about 3 volts. So when I test it, it's 3.32 volts. We'll call it 3.32 volts. And I'm going to make a note of that as well. And what I'm going to do now is reconfigure to measure the current in the circuit once again. So I've reconnected in this other voltage now, which is, as we said, 3.32 volts. And as you can see, the current, it'll be going up here, down through the meter, back through the meter, into the other white lead, and then round the resistance and back to the batteries. So we can see now I've changed the voltage, and we've got 3.32 volts. The resistance remains the same at 20 kiloohms. And now, with a different voltage, we have a different current flowing in the circuit. We now have 0.1 milliamps. So we're going to make a note of that, 0.1 milliamps, which is going to be 0.0001 of an amp. So what we've done so far is we've kept the resistance constant, and we've altered the voltages, and we can see by altering the voltages we can alter the current. Now what I'm going to do finally, I'm going to alter the resistance, and what you should see there on the multimeter is as I alter the resistance, that alters the current value. So all these elements within the circuit are interdependent, and if you change any of these elements, then the circuit dynamic is altered. So if you change the resistance, that alters the current. If you change the voltage, that alters the current. So what we need is a law that unifies all these things, and the law is called Ohm's Law. We mentioned ohms as a unit of resistance. Also, Ohm's Law will tell us what is happening in this circuit. And what Ohm's Law says is the current in the circuit is proportional to the voltage and inversely proportional to the resistance at constant temperature. And we have a formula that goes along with that, hand in hand, and that formula is V, voltage, is equal to I for current times R for resistance. Okay, so here are our results from our experiment. So 20 kiloohms, 9 volts, we get a current of 0.4 milliamps running in it, or 0.0004 amps, and at 3.32 volts, we get a current of 0.1 milliamps, or 0.0001 of an amp. And we're saying that connecting all these together, V is equal to I times R, where V is the voltage in volts, I is the current in amps, and R is the resistance in ohms. Now comes the time to plug in the figures and to see if this is correct. So what I'm going to do first of all, I'm going to do two calculations for the 20 kiloohm resistor at 9 volts and for the 20 kiloohm resistor at 3.32 volts. In our experiments, we did two experiments. Both of them we kept the resistance at 20 kiloohms, and kilo means 1,000, so it's 20,000 ohms. First experiment we had 9.04 volts, and with those two combined we had a current of 0.0004 amps. For the second experiment we connected in 3.32 volts, and for that we measured 0.1 milliamps, and that's 0.0004 .00001 of an amp. So milli is 1,000. So we move the decimal place. We move the decimal point 3 places to the left. So that would be 1, 2, 3. So that's how we work that out. And similarly here, it's 0.4 milliamps. So it's 0.4 thousandth of an amp. So we move the decimal point 3 places to the left. So that's 1, 2, 3, giving us 0.0004 of an amp. So that's just converting milliamps to amps. Now we said that V is equal to IR. Transposing that formula, you can say I is equal to V over R. And in our next video, I'll show you how to make a little pyramid to enable you to transpose that quite easily. But if we're transposing it, we need I on its own. So I is held to R by a multiplication sign. So if we divide both sides by R, that will give us I is equal to V over R, leaving I on its own because that's the value we want. Dropping in the values, so you've got 9.04 volts on the first one with 20,000 ohms. And if we pop those figures into a calculator, it gives us a current of 0.0004 of an amp, which is exactly what we measured. Similarly, for the second scenario, we pop in 3.32 volts, which is there, 20,000 ohms, which is the resistance of the circuit, which we calculate to give us 0.0001 of an amp, and we measured 0.0001 of an amp. So we can say that this Ohm's law, named after George Seaman Ohm, holds water. It's true to form, it works. And that formula is one of the very basic foundation blocks of electrical engineering. So that is really, really important if you wish to understand electricity and how it behaves. That's it for today. So to summarize, we've seen a circuit with a variable resistor in it. We've varied the resistance, we've varied the voltages, and with those we've analysed what happens with the current, and then we've said to connect all these elements together we use Ohm's law, which is V is equal to IR. Crucial bit at the end of that, at constant temperature, and that's something we'll look at in the future. Thank you very much. The next lesson, as I say, we'll start off with a pyramid to show you how to do an easy transposition of that formula, and then we'll have a look at how we connect resistances in series and parallel into circuits. Thank you very much.